dependent probability is a probability where one's action depend on the other. The good example that I can talk about, maybe a dependent event, is whereby we're a family, we're staying home, okay? We're a family, we're staying home, and then when one person gets sick, it's going to affect the rest of the family because members because one is unwell. That's an example of a dependent probability. Now, in a dependent probability, the action of one entity affects the other. So in a situation whereby one entity is picked from the source, let's say a pen is picked from the box of a certain pen of a certain color, it is going to affect the other colors. Why? Because under dependent probability, objects are not returned. Objects are not returned. So because they are not returned, meaning the total number of the objects at the end of the day won't be the same. Will not be the same, because if there were 10 and then one is taken out of the source without being returned, meaning the total will be 10, but it will be 9. Why? Because the entity depends on one another. That's why we are calling it a dependent probability. Example, the same ones that I sent. So the example, but now the dependent probability, I'm going to combine it with a tree diagram. But now the tree diagram, we know that the tree has got branches. But in our tree diagram probability, the number of branches a tree will have will depend on the on the types of entities. I'm gonna say that again. What I'm saying is, in the tree diagram, we know that a tree has got branches, but in our probability, the number of branches that this tree will have will depend on the number of types of entities. If you say this, maybe you're trying to about pens that have got different colors, blue and black, how many types of colors that we have, that's where the number of branches will be determined. Okay, so the first example that was given, which was given, we are saying, which is example 2, is saying a box. So, and I'm going to call it example 1 in our tree diagram, the one that was sent. A box has 3 green discs. So we have 3 green, and we have 5 blue. 5 blue. So we have those types of discs. We have 5 green and we have 5 blue. Now, remember I said a tree has got branches, and the number of branches that this tree will have will depend on it, not the number of entities, but the number of types. So in here, the types that we have are colors. We only have green and blue. So how many types are there? There are only 2. So because there are 2 types of colors in this raffle that we're going to have, or that we have rather, therefore this tree diagram will have only 2 branches. Okay, it will have only 2 branches. So if that is, then we can get started. But it has not ended there. We're just told the number of entities and the tabs in the box. But they're saying 2 discs are picked at random, one after the other, and each color is not then replaced. No. Change there. Say and not replaced, because dependent probability that objects are not returned. So change where it says is noted and then replaced. No, there we are not replacing. So we are saying it is not replaced. Because if it is replaced, meaning is affecting the other entity, of course. So now, if it is not replaced, then the first question says, draw a tree diagram to illustrate the information above. So here what you're supposed to do is let's add the number, not the types, let's add the number of entities. In here, number are 3 plus 5, and the total they are 8. So that's what we have. The total entities there, they are 8. Okay, so now how do you do the tree diagram? Remember, I said that the number of branches will be dependent on the number of types of entities that we have. Because there are only 2 types of colors, therefore this tree of ours will have only 2 branches. Because there are only 2 types of colors, this tree of ours will have only 2 branches. Branches are they? We have the branch green and we have branch which is blue. Only 2. If there were 3, we could have given 3 branches, but there are only 2 branches, of course. But now, from the information that we are given, what is the probability of picking a green? So the probability of picking a green, initially 3 out of 8. Initially, that's how they are. And then the probability of, let me see, the probability of a blue, the blue we are told that they are 5 over 8. This is how the discs are in the box before none of them was taken at random. So if that is how it is going to be, then we are saying that the probability of green here, we have to say that is 3 over 8 before they were picked. Here, the probability of the blue, we are told that is 5 over 8 before they were picked. That's how it's supposed to be. This is do your tree diagram. Having identified or having allocated the branches, the branches are allocated before any of the discs was picked. Now, after the first branches are done, then we are told that 2 were picked at random, one after the other. They were not replaced. So because they were not replaced, now from the green, this is what to do. From the green, again, we are going to have 2 branches. Again, this one be for green, this one for blue. From the blue, again, we are going to have 2 branches. One for green and another one for blue. That's what to do. I'm going to repeat. The number, if the number of types are 3, we initially were supposed to have 3 branches. Because there are 2 only green and blue, that's why nankana branches have it. And now initially before the pick, we have 3 green, and out of 8 blue, 5 out of 8. But now after the picking was done, from each green you are to have 2, and from each blue you also need to have 2. Now once you do that, here we are going to assume that the one which was picked was green. That's what to do. We are going to assume that what was picked here was green. So if it's green which was picked, blue will remain the way it is. So if it is green which is picked from here, how many greens do we have here? Green, there are 3. So if the green which is picked, then my green yazasala yavidi. Out of what? If they pick one green, we are saying this is a dependent which depends on the other. If you pick one green, then the total will no longer be 8, but will be 7. Why? Because one was picked. Now, the assumption we are making is that it is green which was picked. So if it is green which was picked, for blue, blue will still remain 5 as 8. So blue will remain 5, but the total is lost because one green is gone. So we are done this side. Now let's try to come. In the first branch, we assumed that the one which was picked was green. In the second branch, we are going to take the assumption that the one which will be picked is a blue. So if the one which is picked is a blue, initially they were 5, so they will remain 4. And if the one picked is blue, they were 8, then they will remain 7. But if the one picked was blue, what about the green? The green will remain the way they were, which is 3, but the total has reduced to 7. So that is how you can present a diagram. First thing is how many types of items are we given? We'll determine the number of branches. Then from each branch, again, we're going to have subdivision of branches. Subdivision of how many branches? Like the ones you have had at the beginning. Here we had 3, na pass ankala na 3. If here we had 3, we could have 3. So that is how you can do the diagram. Unmute the camera and ask if you have not understood. Now, if that is okay, then let's go to the second question. The second question is saying, let me just locate it. The second question is saying that okay. The second one is saying that find the probability that both that were picked are blue. Now remember, when you say both, we're talking about both this and that. When and is, it means what you're supposed to do there is to multiply. So that is B what? That's B now, B1. So B1 is talking about both being what? Find the probability that both are blue discs. So if both are blue, we are going to say the probability of blue and we multiply the probability of blue multiply. Now, come here, what is the probability of finding? Now, when you say probability of finding blue and blue, so we are going to say this blue and the blue. When they say probability of blue, go to the branches that you have, then go and pick the one for blue. So the branch that we have for blue is this one. The branch that we have for blue one, whose probability is 5 or 8. Then we are going to multiply the same branch. Then we follow another one which is blue. Another one which is blue is 4 or 7. Is the probability of finding both that were blue. So there we're just going to multiply. So 5 times 4, that will give us 20, over 8 by 7, that is 56. So that is the probability that discs that were picked are blue.
Sir.
Yes.
Why not just reduce it, like you can do 2 into 8? Wait, yeah. Because 2 can go into 4 and 2 can go into 8. So then you can reduce it instead of having 20 over, that is 56.
You are the boss. So here 2, here 4. So that 2 by 5, that will give us 10. And then 4 by 7, that is 28, right?
Yes.
Yeah, can also work. Yeah, you can also work. Is as good as having 2 into 20, which is 10, 2 into 5, 2 into 5, which is 2, 1, we put per 6 in 16, 2 into 16, that is 8. So any of the two can work. So that is how you can do the probability finding both disks that were blue.
Sir,
Yes.
there you've written 4/7. Isn't it 2/7? Because, oh, sorry, it's fine.
Yeah, it's fine. 2 unless it was green, but we're talking about blue.
Oh, I started with green. Oh,
No. We're
fine.
not talking about green here. You can't. The only time you can start with unless green and blue,
Mm.
unless green blue.
Sir, but you
Yes.
can do 4 into 8. 4 there, 1, 4 there. It will be 4. 4 there, 1, 4 there, 2. Then it will be 5 times 1. Then it will be 5/14. That's what you get as
Here,
your answer.
here,
No, if you reduce
here,
it,
here.
yes,
Even here,
yes, because 4
even
can go into 8.
even here, 2 into 10, that is 5, and then 2 into,
Or
that is, yeah, you can really,
14.
yeah, definitely.
Okay.
I was just showing you the method, the reduction. You can do that even on your own. Okay, now another one says find the probability that both disks are of different colors. Both disks are of different colors. Both disks are of different colors. Now there is a combination, Mali. Muka, you have to pay attention to this. Both disks are of different colors. Now, different colors can be, look here, different colors can be green, blue, or blue, green. Are you seeing that? So meaning they are doing a combination of and O. So different colors, we're going to say the probability of blue and green, or the probability of green and blue, because these are different colors. So what's the probability of blue and green? Start with the first branch. The first branch is blue. So what is a blue? The blue here is 8/5. So 8/5, 8/5 times blue green.
2/7.
Kwa mene uko ku blue then ku green now mwali
Or green.
3/7.
Why isn't it 2/7?
Mwali, look here. Here we took because it's a green branch. We said we are going to take an assumption that the one which was taken was green. Blue remained the way it was. It is not
Blue,
a,
it remained the way it was, but
yes.
we're getting green now. So, because we've
Wait,
already removed one green, won't it be
wait,
2/7?
wait. These assumptions we are taking. The moment we took an assumption that the one which was taken was green, the blue remained the way it was. Now we are done on the first branch. When you go to the second branch, now we are taking an assumption because this is the blue branch. We are taking, because it's a blue branch, taking an assumption that the one which was taken now was a blue. So the only one which is reducing is a blue, and the green remains the way it was. Are you seeing?
Yes.
Do not say because this one has reduced even these assumptions. This is a different branch. When mangoes
Okay.
the mangoes are getting ripe in one branch, it does not affect the other branch. Should start arguing at mangoes, why aren't you getting ripe? Your friend, look at what's happening. This assumption. This is a different branch and it's a different branch. So when you say blue, green, talking about the same branch. So this is blue, then green will be 3 over, over 8, sorry. So over 7, or we're going to add, then now this is green. So you go to the green branch, which is 3 over 8, 3 over 8 by, now the blue is this one here, which is 5 over 7. So 3 by 5, that is 15, and 7 by 8, that's 56, plus 3 by 5, that's 15, 7 by 8, that is 56. 56, and you know these are common denominators, the denominator is the same, so we're going to have 56, and then when we add 15 and 15, we get 30, and we know 30, 15, 30, 56 can be reduced and to a very small number. Yeah, so if you want, you can use the 2 into 30 here will give you 15, and the 2 into 56 will give you 28. So that is the probability of picking 2 different colors. The different colors can be blue, green, or green, blue. Muka, why aren't you participating in asking questions? You don't usually ask questions. What is it? Do you always get everything right? Muka, you are there.
I'm here, sir.
But why are you not just getting everything right?
I'm following. I
Okay.
understand.
Okay, even better. Okay, is the second part of part B. Then the other one is saying first blue disc, then different color. So first blue and any other color. So we are not saying there's a difference between the way the question has come and when they say at least one blue. When they say at least one blue, meaning we are going to follow all those combinations where we will have one blue. But according to the way the question is saying, the first one is blue. So meaning you consider the probability of one which is and the probability of the other one, of course, it is green. That's what it means because they're only, so one is blue, then the other one ought to be green. So the probability of blue here is 5 over 8 by the other one, which is green, will be 3 over 7, and will be 15 over 56. So that is the probability of picking the first one blue, then the other one ought to be a different color. That is how it is to be done. Yeah. Are we okay?
Yes.
Yes.
We go to the last one of the examples that I'd sent you. Yeah, so the tree diagram is very simple. The first thing is on each branch you take an assumption according to the branch you are following. If you are following the green branch, then the assumption should only be the fact that branch is taken is green. The rest of them should be the way they are. But now the moment you go to a different branch, and the assumption now should also be in line with the branch that you are following. The rest of the color should remain unaffected. Then the last one is on the question 5. I don't know which year is this. I'm yet to find out. So we are saying that in this box now, how many types of entities that we have there? There are 3. So we are saying that they contain white chalk. The probability of white is 5, blue 4, and yellow, which is 3. So these are the 3 colors of chalks, that pieces of chalk that we have. So total, how many are they? So number of expected total outcomes will be 5 plus 4 plus 3.
12.
That's 12. Yeah, very good. That's 12. So the total number of pieces of chalks in there were 12. Then the question is like, okay, a piece of chalk is selected at random from the box and not replaced. Okay. Then another one is selected. So draw a diagram. So the tree diagram is just the same thing. The only difference is that I decided to pick on this question because now we did with the one 2 branches. This one now has got 3, but the procedure is just the same. So from the initial point of it, I'm going to have 3 colors or 3 branches. Okay, that's what I'll have. I will have 3 branches because we have 3 types of colors. So we have white here, we have blue here, and then we got yellow. So the probability of picking a white, the probability of picking a white here, white will be 5/12. Of picking blue here will be 4/12. And then yellow will be 3/12 before any selection is done. Okay, so meaning on the white part, we are told that white were 5. So here we will have 5/12, 5/12, and then on the blue is 4/12. Then here it's 3/12. That is what we have. Then once that is done, because this is a yellow branch, okay, remember again from the yellow, we are going to have 3 branches from the same yellow. From the blue, we also have 3. From the yellow or blue, just like that, just like that. So this is white here. In the same order, the next one is blue, the last one is yellow. This is the first one is white, second one is blue, the other one is yellow. First one is white, second one is blue, and the last one is yellow. The same way they are arranged, the same way they will be arranged on each branch. So because these assumptions, so the first assumption goes to what? The first assumption goes to white. The one picked is white. Initially, they are 5. So when you pick one, they will remain 4. Because there were 12, when one goes out, they will remain 11. So if it is only white which is taken, the assumption is only on white because it's a white branch. The rest of the blue and the yellow will remain the way they were. So blue, they were 4, but because one is taken, they will remain 11. Then yellow, they were 3, and they will be 3 as they are. But the moment one goes out, will reduce to 11. That's what we do. So we are done with the blue with the white branch. We go to the blue branch. So meaning because this is blue, the assumption will only be on a blue. Therefore, white will remain the way it was area 5, but the total goes to 11. The assumption now is on blue. So blue, there were 4. Now they are remaining 3, but the total will be 11. The yellow will remain the way it was earlier, is 3, but the total has reduced to 11. Now we are on the yellow branch, so the assumption only be on the yellow. Yellow initially there were 3, so there will remain 2/11. So because the assumption is only on the yellow branch, yellow color, the rest of them blue will remain the way it was, which is 4/12, and white it was, which is 5 of, oh sorry, they will remain 11 because one has been picked according to the assumption. Any question with the tree diagram on how to locate probabilities? So the question now says, find the probability that the chalk which is selected is of the same color. So if it is of the same color, it must be probability of white and white, or the probability of blue and blue, or the probability of yellow and yellow. That's what it means, because they are the same color. Then we start fusing in. So we'll say white is 5/12 multiplied by the other white on the white branch is 4/11. Or we are going to add, now the blue is 4/12 multiplied by the other blue on the blue branch is 3/11. We add to the yellow 3/12. Sorry, there's someone knocking by the door. Okay, I lost that. So now we're on the yellow part. The first part of the yellow is 3. So it will be 3/12 multiplied by the other yellow will be now 2/11. So it is 2/11. That is now is very simple algebraic expression that we have. So 5/4, which is 20/11/12. What's that? 132. We add to 3/4, that is 12. 11/12, that is 132, plus 23, that is 6/11/12, that is 36. Now, if you look at the denominators, the denominators are common. So we are just going to add the numerators. So the numerators that we have are 26 and 12, and that will give us 38/132, which you can reduce to the smallest number of your choice. So that is how you can deal with the tree diagrams. So any question?
No. No question.
Have you?
Yes.
Okay, so I'm going to send you work for both physics and math. But there must be a difference, guys, between you and the others when you open. At least we should have moved further in the understanding.
Yes, sir.
Yes.
Okay, bye.
Bye.